Hi, I am Sashwat Barua, and today I am going to discuss about Hyperbranched epoxy nanocomposites. Let us begin by appreciating the beauty of nature. In nature, symmetry is the beauty, and nature has created many highly branched structures which are efficient in their function as well as they are beautiful. Keeping this in mind, material scientists tried to mimic nature's highly branched structures and developed highly branched polymers. Highly branched polymers or dendritic polymers fall into two categories, dendrimers and hyperbranched polymers. Their basic difference is there in their structural units. Dendrimers are globular, symmetrical entities where the structural units are branching points, surface groups, and a core, whereas in hyperbranched polymers, three distinct structural units are there: linear, dendritic, and terminal units. There are some advantages of hyperbranched polymers over dendrimers. They are easy to prepare, they don't need purification, low viscosity, high solubility, low polydispersibility, and they are feasible for industrial purpose. Epoxy thermoset is a product of epoxide resin and polyamine hardener. The conventional way for preparing epoxy is by reacting bisphenol A and epichlorohydrin. However, the conventional epoxy systems have some of the demerits like brittleness, thus low toughness, and non-biodegradability. Keeping this in mind, material scientists tried to develop hyperbranched epoxy systems. Epoxy thermosets have wide range of applications. They are regarded as structural adhesives. They have utility in electrical industries, paints, coatings, and in biomedical domain also. They are utilized as root canal sealers, surgical sealants, etc. To gain different interesting properties, we tried to design hyperbranched epoxy nanocomposites. For our purpose, the utilization of the nanomaterials like graphene, reduced graphene oxide, carbon nanotube, nanoclay, and metal nanoparticles are selected. Carbon-based nanomaterials and nanoclay are selected for gaining high mechanical properties, whereas metal nanoparticles are chosen for gaining interesting biological properties like antimicrobial activity. We have targeted some applications for our nanocomposites like high performance coating material, biocompatible coating, antimicrobial coating, non-toxic surgical sealants, wound dressing materials with adequate derma compatibility, and polymeric implantable biomaterials. These are some references used here. And finally, I would like to thank my supervisor Professor Niranjan Karak for his support, Sir Harold Kroto for his inspiration, Tezpur University for supporting my research, and NRB India for financial support. Lastly, thank you all for your kind attention.